Good morning, class. Today we're going to be going over the Unit 5 review. So we'll go ahead and get started here. All right, so number 1A, determine two coterminal angles, one positive and one negative. All right, remember for coterminal angles, all you have to do is add or subtract 360 degrees for degree measure and 2 pi for radian measure. So here, if you notice that this is, of course, you could go ahead and add 360 to get 860. That would be perfectly fine. But if you notice that this is already over 360, if you subtract 360, right, you're going to get 140 degrees. Right, that is a positive angle, so there is your positive coterminal angle. All right. Well, if you subtract 360 again, all right, now you get negative 220 degrees. All right, that is a negative angle, so that counts as your negative coterminal angle. That's it. Of course, there's others, right? Like I said, you could have added 360 to get 860. Of course, if you subtracted 360 again, all right, you could get negative 580. There's infinite of them. Of course, it's kind of silly to go much more farther than needed. All right, so here we're going to be, again, we would add or subtract 2 pi. Again, now here you're going to have to find a common denominator. All right, so 2 pi is equal to 12 pi. All right, so it's equal to 12 pi over 6, obviously, because 12 over 6 is equal to 2. All right. Again, if you notice that this is larger than 2 pi, you can kind of do the same thing we did over here, where you don't necessarily have to add right off the bat. If you subtract 12 pi over 6 from here, all right, then you will get 5 pi over 6, which is a positive angle. So there's your positive coterminal angle. All right. If we subtract 12 pi over 6 again, all right, well, now we get negative 7 pi over 6. All right, this is a negative angle, obviously, so there's my negative coterminal angle. I have one positive, one negative. I'm good to go. All right, number 2, convert each to radians. To convert to radians, all you have to do is multiply by pi over 180 degrees. So here are my degrees, and even my zeros here will cancel. All right, so now that leaves us with 14 pi over 18. All right, that simplifies to 7 pi over 9. Over here, same thing. We multiply this by pi over 180 degrees. All right, so we can simplify here. 35 over 18 doesn't reduce, so this is just 35 pi over 18. And we are done. All right, convert each to degrees. So now we're going the other way. So now we multiply by 180 over pi. You just flip it, right? Whichever one you want to get to goes on top, okay? So here, our pi's will cancel. 180 divided by 10 is 18, all right? And 9 times 18, 90 and 72 make 162 degrees. Same thing here, multiply by 180 degrees over pi. My pi's cancel. All right, 180 over 5 would be, 36? All right, so 4 times 36, 144. And we are done. All right, name the quadrant in which theta lies. Remember, this is where we use our all students take calculus. All right, so in the first quadrant, all trig functions are positive. In the second quadrant, sine of theta is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. Of course, the reciprocals are also positive as well. So where sine is positive, cosecant is positive. Where tangent is positive, cotangent is positive. And where cosine is positive, secant is positive. So here it says, okay, well, where is cosine positive, but cosecant negative, right? Greater than 0 means positive, less than 0 means negative. Remember, cosecant is the same as sine, right, as far as sines are concerned. All right, so where is cosine positive but sine negative? Here in quadrant 4. All right, where is tangent positive but sine negative? That would happen here in quadrant 3. And where is sine positive but cosine negative? That would happen here in quadrant 2. All right, 5. Find the exact value of each expression. All right, these are coming straight from the unit circle. Remember, on your unit circle, all right, sine is your y coordinate, cosine is your x coordinate, tangent is your y coordinate divided by your x coordinate, right? And then for all the reciprocal functions, you just flip them, all right? So sine is the y coordinate, so you go to pi over 6 on your unit circle and say, what is my y coordinate there? It's 1/2. All right, cosine of 3 pi over 2. What is cosine of 3 pi over 2? You go look at your x coordinate there. That should be 0. All right. Some more just like it. Sine of 7 pi over 4. You go to 7 pi over 4. Look at your y coordinate. This is a negative square root of 2 over 2. All right. D, negative pi over 6. Remember, positive is going in the counterclockwise direction. Negative is going in the clockwise direction. Of course, if you don't like to think of it like that, just find a coterminal angle. So if you add 2 pi to this, which is 12 pi over 6, this is really the same as tangent of 11 pi over 6. So you go to 11 pi over 6, look at your tangent there. It's going to be negative square root of 3 over 3. All right, secant of 7 pi over 6. Secant is not on my unit circle, all right, but its reciprocal buddy, cosine, is. So if you look at cosine of 7 pi over 6, that's a negative square root of 3 over 2, which means for secant, you would flip that, so negative 2 over the square root of 3, and when you rationalize that, you get negative 2 square roots of 3 over 3. All right, cotangent, we kind of do the same thing. We say, okay, well, cotangent isn't on our unit circle, but tangent is. So what is tangent of 5 pi over 3? All right, tangent of 5 pi over 3 is negative the square root of 3. All right, so this would equal negative 1 over the square root of 3, which when rationalized is negative square root of 3 over 3. All right, continuing on, 25 pi over 6, definitely not on our unit circle. It's too large, so we need to find a coterminal angle. So if I subtract 12 pi over 6, which is 2 pi, I would get 13 pi over 6, still too big. If I subtract 12 pi over 6 again, I get pi over 6. All right, so this is the same as the cosine of pi over 6, which is simply the square root of 3 over 2. All right, and then tangent of 5 pi over 3, that's just negative the square root of 3. All right, number 6, find the exact value. Here we just use some of our trigonometric identities. All right, here we have an identity that says sine squared theta plus cosine squared theta is equal to 1. All right, so as long as these two angles are the same, then this just equals 1. Well, these two angles are the same, so this just equals 1. All right, cosine of 1.2 times secant of 1.2. All right, we have a reciprocal identity that says secant of theta is equal to 1 over cosine of theta. So here we have cosine of 1.2, But instead of secant of 1.2, I can rewrite that as 1 over cosine of 1.2. Well, now, you really don't need to show this, but if you actually multiply this, you get cosine of 1.2 over cosine of 1.2. Well, what is anything divided by itself? Just 1. I find the exact value of each of the remaining trigonometric functions. Right? Tangent theta equals 3/10, and theta lies in quadrant 2. There was a small typo here. Obviously, if we're in quadrant 2, tangent is always negative, so this has to be negative 3/10. All right, so we know that we're in quadrant 2, so I can simply draw an angle in quadrant 2. My theta is always right here next to my origin inside the triangle. All right, tangent is opposite over adjacent. So I have 3 here, I have 10 here. Obviously, one of these has to be negative. All right, well, if we're going from the origin, to the left means negative, and up means positive. So my 10 here has to be negative. I can use my Pythagorean theorem here, all right, and this is just going to be the square root of 109. So now I can find all of my other trig functions. Okay, so sine of theta is equal to opposite over hypotenuse. So 3 over root 109, right, which is the same thing as 3 root 109 over 109. All right, of course, for cosecant, I just flip that. It's much easier to flip your pre-rationalized fraction here, and you just get the square root of 109 over 3. All right, cosine of theta, all right, is equal to adjacent over hypotenuse. So negative 10 over root 109. Of course, rationalized, that's negative 10 root 109 over 109. And secant, of course, is just the reciprocal of that. Again, flip the pre-rationalized to get the square root of 109 over negative 10. Tangent they gave us, so we don't have to find that. But cotangent, we just flip what tangent is. So negative 10/3. Done. All right, doing the same thing here. Again, we're in quadrant 2. So I draw an angle in quadrant 2. Here's my theta.
Mr. Hooker, please report to the bus entrance for duty. Mr. Hooker, please report to the bus entrance for duty. Thank you.
All right, now secant isn't part of our SOHCAHTOA, but cosine, its reciprocal buddy, is. So we can just flip this as negative 5 over 13. All right, cosine is opposite over hypotenuse. The hypotenuse is never negative. I'm sorry, it's adjacent. I'm an idiot. All right, so this will be negative 5 over 13. You can use the Pythagorean theorem here. Do be careful to make this your c, right? A squared plus b squared equals c squared. Hypotenuse always has to be c. But this is just a Pythagorean triple. This is a 5, 12, 13 Pythagorean triple. So if you know that, you don't need to do that small math. So now we can go ahead and do all of our trigonometric ratios. So sine of theta is opposite over hypotenuse, which means cosecant of theta is its reciprocal. Cosine they gave us. Actually, no, they did not. Cosine we kind of found up there, negative 5/13. Secant they gave us, so you don't have to rewrite that down. Of course, if you do, it doesn't really matter. All right, tangent of theta is equal to opposite over adjacent, so 12 over negative 5. And cotangent of theta is that reciprocal, so negative 5/12. So lots of SOHCAHTOA going on there. All right, number 8. If the terminal ray of angle theta in standard position passes through 5, negative 2, find the values of the 6 trigonometric functions. All right, well, 5, negative 2, if you think about it, is in the 4th quadrant. I think it's easiest to just draw a triangle. So in the 4th quadrant, all right, here's my triangle, here's my theta. All right, 5 tells me to go to the right 5, negative 2 tells me to go down 2. All right, I go a squared plus b squared equals c squared, so this is the square root of 29. Do be careful that you want to check to see if this rationalizes, or simplifies rather. If it simplifies, you definitely want to simplify it. In this case, it does not. All right, so here we just use SOHCAHTOA again. All right, so sine of theta is opposite over hypotenuse, so negative 2 over root 29. Of course, we have to rationalize, so that's negative 2 root 29 over 29. All right, cosecant, it's reciprocal. Remember, just do the pre-rationalized version here to get square root of 29 over negative 2. Cosine of theta is adjacent over hypotenuse, so 5 over root 29, which again, rationalized, is 5 root 29 over 29. So it's reciprocal, secant of theta, just flip this, is the square root of 29 over 5. And tangent of theta is opposite over adjacent, so that's negative 2/5. So cotangent of theta is equal to negative 5/2. Again, lots of SOHCAHTOA. All right, calculator section. Find the exact value of each of the 6 trigonometric functions of angle Q. So we're looking here. Again, lots of SOHCAHTOA. All right, so sine of Q is equal to opposite over hypotenuse, so 8 over 17, which means cosecant of Q is going to be 17 over 8. Cosine of Q is going to be adjacent over hypotenuse, so 15 over 17, which means secant of Q is going to be 17 over 15. And tangent of Q is going to be opposite over adjacent, so 8 over 15. So cotangent of Q is its reciprocal, 15 over 8. Hopefully you're seeing a theme by this point, lots of SOHCAHTOA. So please remember SOHCAHTOA. All right, solve for x and y. All right, here we're using more SOHCAHTOA. You can only solve for one at a time. I'll solve for x first. All right, so from my angle here, x is my opposite, 14 is my hypotenuse. Opposite and hypotenuse is sine. So sine of 43 degrees is equal to x over 14. So to solve, all I have to do is multiply both sides by 14. Plug this into your calculator. You do want to be very careful here that you are in degree mode because our angle is in degrees. So 14 sine of 43 is 9.548. And please round to 3 decimal places. Right now to find y. Y is my adjacent, and 14 is still my hypotenuse. Adjacent and hypotenuse is cosine. So I say cosine of 43 is equal to y over 14. So I do the same thing, multiply both sides by 14. Plug this into my calculator, and we get 10.239. Done. All right, number 11. Kirsten places her surveyor's telescope on the top of a tripod 5 feet above the ground. She measures an 8-degree elevation above the horizontal to the top of a tree that is 120 feet away. How tall is the tree? Okay, so we have the ground. Okay, we have a tripod with her little measuring device on it. All right, we have a tree. All right, now the horizontal here, we know that this is 5 feet. All right, so looking at the top of the tree, all right, this is 8 degrees. All right, so I want to know this h. All right, so of course, we know that we're 120 feet away from the tree. All right, so this is opposite, this is adjacent, so that's tangent. So tangent of 8 degrees is equal to h over 120. So I multiplied both sides by 120. All right, so 120 tan of 8 degrees. Seems very, very small, but okay. 120 times tan of 8. Okay. So 16.865. So H equals 16.865. Now we have to be very careful. This is only telling us this piece, right? Because we were looking at this triangle with these dotted lines. So it's not counting this 5 feet here. So we really do have to be careful to add that 5 feet. So the tree is actually 21.865 feet. So do be careful there. All right, find the reference angle for each angle. All right, I think of this as just the fastest way to the x-axis. You can remember all of the little rules, where of course if you're a second angle quadrant, you just do 180 minus the angle, or pi minus the angle. If you're in the third quadrant, right, you do the angle minus 180, or the angle minus pi. All right, if you're a fourth quadrant, you do 360 minus the angle, or 2 pi minus the angle. Okay, so whichever way you want to think about it. I'll go ahead and use the formulas, I guess. So here we're in the fourth quadrant, so all I have to do is say, okay, well, 360 minus 312, and that is 48 degrees. All right, so that's my theta prime, which is my reference angle. All right, here we don't like this, so if we add 360, that's going to give me 110 degrees. That's going to be in quadrant 2. So in quadrant 2, you take 180 minus the angle to give me 70. So that is my theta prime, my reference angle. Now we're in radians. All right, it's a little bit harder to tell what quadrant you're in with radians. All right, so remember here, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and then we're back here at 2 pi. Pi we know is 3.14, so 2 pi we know is 6.28. Pi over 2, you just cut 3.14 in half, and that's 1.57. 3 pi over 2 is 1.5 pi, so just add 1.5 pi, and you get 4.71. Okay, so 3.0 would be somewhere down here, right? So we're in the second quadrant, so you would do pi minus 3.0. So 3.14 minus 3.0 is 0.14. 4.7 would be over here, so it's just barely in my third quadrant, all right? So that's when we actually do our angle minus pi. So 4.7 minus 3.14 is equal to 1.56. All right, 13. Find the remaining trigonometric function using trigonometric identities. So now we're not allowed to draw a triangle and use SOHCAHTOA. If you try that on the test, you will miss all of the points for the work because it specifically tells you to use identities, okay? So secant, the easy one to find here, so I'm going to need to find sine of theta, cosine of theta, tangent of theta, and all of their reciprocals, cosecant of theta, secant of theta, and cotangent of theta. All right, so secant, they tell us, right? So we know this is 5/3. All right, well, we know that this is 3/5. All right, now it tells us this is a fourth quadrant angle, right? So in our all students take calculus, we know that cosine should be positive and secant. So all of these other ones are going to be negative. All right, well, there's several different ways that we can go about doing this. We can always use that, since we know sine or cosine, that sine squared theta plus cosine squared theta is equal to 1. All right, so I know cosine theta, so sine squared theta plus cosine is 3/5, so cosine squared is 3/5 squared is equal to 1. All right, so sine squared theta is equal to 9 over 25. Whoops, sorry, not equal to. All right, so sine squared theta plus 9 over 25 is equal to 1, which is just 25 over 25. Subtract 9 out of 25 from both sides, and you get 16 over 25. We don't want sine squared, we just want sine, so we take the square root of both sides, and we get that the sine of theta is equal to 4 over 5. Now, we know we're in the fourth quadrant, and we know sine is negative in the fourth quadrant, so I make this negative. So this is negative 4/5, which means this is negative 5/4. All right, now to find tangent and cotangent, if we use our quotient identities, tangent of theta is equal to sine of theta over cosine of theta, which is equal to 4/5 divided by 3/5. So of course these 5's just cancel, and we get 4/3, which means cotangent is 3/4. So we only needed to use 2 trig identities. Also, you'll be allowed to use the trig identities on the test. You don't have to have these things memorized. I'll put under like materials as a material, I'll just post a formula sheet, which basically has all of the trigonometric identities on there for you. So you won't have to remember those. All right, 14. A neighborhood carnival has a merry-go-round whose radius is 40 feet. If the time for one revolution is 55 seconds, what is the linear and angular speed of the merry-go-round? So do remember that linear speed is equal to theta over t, and angular speed is equal to the arc length over t, which the arc length is just r times theta. All right, so we go ahead and plug this in. All right, it says if the time for one revolution is 50 seconds. All right, so first we'll talk about, whoops, and I have these backwards. This should be linear speed, and this should be angular speed. All right, so if we're talking about angular speed, one revolution in radians is simply 2 pi. So that's what my angle is, because we went one revolution. And of course, my time is 55 seconds. All right, you can plug that into your calculator and do actually use the pi button. So if we say 2 pi divided by 55 seconds, all right, we will get 0.114 radians per second. All right, linear speed is really the exact same thing, except I'm multiplying by the radius. So now I have 40. I'm still going one revolution, so my theta is still 2 pi, right, and the time is still 55 seconds. So if you plug that into your calculator, you get 4.570 if you round correctly. All right, and this would be feet per second. And that is it. All right, one last problem. A satellite in a circular orbit 900 kilometers above Earth makes one complete revolution every 128 minutes. What is the linear speed? Assume that the Earth is a sphere of radius 6,400 kilometers. All right, so we have the Earth. All right, actually, it's hard to draw circles on this thing, so let's go ahead and make them nice. All right, so we have the Earth. There's the Earth. All right, now we also have a satellite going around the Earth. All right, so So there's a circular orbit around the Earth. All right, so it tells us that the Earth is a sphere with a radius of 6,400 kilometers. And then it says that the satellite orbit is 900 kilometers above Earth. All right, so we will add these together to get my total radius, which will be 7,300. Okay, so now we're still doing linear speed, right? So linear speed is equal to r times theta over t. All right, it says that it completes one revolution every 128 minutes. Okay, so we know that the radius is 7,300. Right, we know that the theta, the angle, it says one complete revolution. So again, we know that that is 2 pi. And we know that it took 128 minutes. That's just going to tell us that we're going to have kilometers per minute here. So simply plug that into our calculator. And you get 358.338 kilometers per minute. All right, and that's it. So that is all we have for the review. If you have any further questions or need anything else, just let me know.